Understand how to read photoelectron spectroscopy, PES, graphs. X-axis. Binding energy indicates the energy required to remove an electron from a specific subshell, measured in mJ/moles. Note that the x-axis scale is typically reversed, decreasing from left to right. Peaks with higher binding energies correspond to inner shell electrons that are closer to the nucleus, while peaks with lower binding energies correspond to Vla shell electrons. Y-axis. Relative number of electrons. The height of each peak is directly proportional to the number of electrons residing in that particular subshell. Analyze the PES of element X to determine its electron configuration. Peak 1. At approximately 5.4 mJ/moles, this high-energy peak represents the innermost core subshell, 1s. Its height corresponds to 2 electrons, 1s to the power 2. Peak 2. At approximately 0.4 mJ/moles, this lower energy peak represents the valence subshell, 2s. Its height is exactly half that of the first peak, corresponding to 1 electron, 2s to the power 1. Total configuration for X, 1s to the power 2, 2s to the power 1, 3 total electrons. Element X is a neutral lithium, Li, atom, which has a nuclear charge of +3. Analyze the PES of element Y to determine its electron configuration. Peak 1, at approximately 11.5 mJ/moles, represents the innermost 1 subshell. Its height corresponds to 2 electrons, 1s to the power 2. Peak 2, at approximately 0.9 mJ/moles, represents the valence 2 subshell. Its height is equal to the first peak, corresponding to 2 electrons, 2s to the power 2. Total configuration for Y, 1s to the power 2, 2s to the power 2, for total electrons. Element Y is a neutral beryllium, Be, atom, which has a nuclear charge of +4. Compare the binding energies of the two elements using Coulomb's law. Coulomb's law states that the electrostatic attractive force, F, between the positively charged nucleus and an electron is directly proportional to the magnitude of the charges, Q1, Q2, and inversely proportional to the square of the distance between them. Rf equals k Q1 Q2 over r to the power 2. Comparing corresponding peaks, such as the 1's peaks. 5.4 mJ/moles for X versus 11.5 mJ/moles for Y. We observe that every peak of element Y is shifted to a significantly higher binding energy than the corresponding peak of element X. Because both elements have their valence electrons in the same principal energy level, N equals 2, the significantly stronger electrostatic attraction pulling Y's electrons closer to its nucleus is driven by a greater nuclear charge, more protons in the nucleus of Y than X. Conclude. This comparative shift in binding energy provides direct evidence that element Y has a greater nuclear charge than element X. Confirming option C is the correct answer. The correct answer is option C. Element Y has a greater nuclear charge than element X does.